All right, so we're going to take the derivative of this using the chain rule. Now, first we should prove the chain rule, but I just spent a long time trying to do that, and I can't do it in a nice, understandable way. So here's how here's how we're gonna do it instead. We're gonna see these three things we got at the top. We're gonna take the derivative of those using the chain rule, and we're gonna take the derivative of them without using the chain rule. And we're gonna show that we get the same thing. So first off, what is the chain rule? The chain rule is that if we're trying to take the derivative, not like that. You go, if we're trying to take the derivative of f of g of x, what that is the derivative of f of x, or no, the derivative of f prime of g of x times the derivative of g of x. That's what the chain rule tells us. So here's what we're going to do. We're going to go through these one by one. We're going to take the derivative of them how we already know how, and then we're going to take the derivative using the chain rule, and then we're going to show that it works. We're going to show that they're the same. So let's take the first function. So let's do it normal first. So x squared plus 1 squared. How would we do that? Well, we would multiply it all out and then use the power rule. So what do we get when we multiply all that out? We get x to the fourth plus 2x squared plus 1. So what is the derivative of that? The derivative of that is 4x cubed plus 4x. Okay, now we're going to take the derivative of that using the chain rule. So if we use the chain rule, what are we going to do? Well, we have to see what our inside function and our outside function is. So our inside function is x squared plus 1, and then our outside function is just the squared function. So we're going to have to use the power rule to take the derivative of the outside function. So we'll bring the 2 to the front, multiply that by x squared plus 1. But then we have to multiply by the derivative of the inside, which is 2x. And now if we multiply all that out, we distribute everything, we get 4x squared. No. We get 4x cubed plus 4x. And look, that's the same thing we got using the other method. So just to be clear, this does not prove the chain rule. This just is our examples of showing it working, showing that you can use the chain rule or the other methods and still get the same answer. So the next one's an interesting one. The next one, just f of x divided by g of x. I don't want to get rid of that just yet. So notice that that's just a quotient rule thing. So we already know the derivative of that because it's just the quotient rule. F prime of x times g of x minus f of x g prime of x divided by g of x squared. So that's just using the quotient rule, which is probably the better way, not going to lie. But we could also use the product rule. If we rewrote this function, the original function, as f of x times g of x to the negative 1. Now we can use product rule and chain rule. So what is this going to be? Well, product rule tells us to take the derivative of the first one times just that normal function, and then add the first normal function times the derivative of the second function. And now the derivative of this function is where we're using chain rule. Because see, it's g to the g of x, that's the inside function, raised to the negative 1. So we have to do some power rule there, where we bring that negative 1 to the front, and then we multiply by, or then we decrease the power by 1. So that's the power rule part. But then because of the chain rule, we have to multiply by the derivative of the inside function. We have to multiply by g prime of x. And then let's fix that up a little bit. So what does this look like? Let's get rid of the negative exponents. So we have f prime of x over g of x plus, or should I say because of the negative 1, minus f of x times g prime of x over g of x squared. And you see, now we basically got it. We just need a common denominator, so we need to multiply this by g of x, and then we combine those fractions, and you see we do indeed get the quotient rule. We have f prime of x times g of x minus f of x times g prime of x over g of x squared. And so again, we took the derivative using two different methods, one of them the chain rule, the other one the quotient rule, and we got the same answer. So that is, could you say, I guess that's more evidence that the chain rule is correct. We're not proving it. We're just kind of doing more and more examples to convince ourselves. But that was pretty good. We showed that you don't need to use a quotient rule. You could just use the product rule and chain rule. And then let's do this last one. This one is interesting because, for one, we just see what is the square root of x squared. Well, the square root of x squared is simply x. And what's the derivative of x? The derivative of x is simply 1. So we should get 1 as an answer. So how do we take the derivative of this using the chain rule? Well, we have our inside function and our outside function. So our outside function is the square root. So what's the derivative of the square root? We've done that. That's 1 over 2 root. And chain rule tells us we keep that the same, but then we multiply by the derivative of the inside, the derivative of x squared, which is 2x. And then we'll simplify from there. So right away we see the 2's cancel. Like we said, the square root of x squared is x, so we're left with x over x, which just cancels to get 1. So again, see that we did this in two separate ways. We simplified first, and then took the derivative and got 1. Then we used the chain rule and took the derivative and got 1. And so again, since we got the same answer both ways, that is even more evidence that the chain rule works. So now that we've pretty much convinced ourselves of the chain rule, let's actually do this problem. So how are we going to do this problem? Well, just like before, we got to see what the inside function is and what the outside function is. So the outside function is just the cubed, because that whole equation in the middle is being cubed. So the first thing we're going to do is we're going to do the power rule, because that's how you take the derivative of cubed. So we're going to do that. We're going to bring the 3 to the front, and then decrease the power by 1. And see how chain rule, the inside just stays the same. But then we multiply by the derivative of the inside. So what is the inside? X squared plus 1. So what's the derivative of that? 2x. And there we go. That's our derivative. So we get 6x times x squared plus 1 squared. That's our derivative. I am kind of curious, though. I kind of want to do this in two separate ways, too. So let's go ahead and multiply this out. So we just get it as a nice polynomial. And then let's take the derivative another way and show that we get the same polynomial. So this is what we get as the derivative here. And then let's do it a different way. So before we take the derivative, let's actually multiply this out. So let's try to do it quickly using Pascal's triangle. So it's going to be x to the 6th plus 3x to the 4th. Oh yeah, plus 3x squared plus 1. Yeah, that was a lot easier than I thought it was going to be. So that's x squared plus 1 cubed. And if we take the derivative of that, what do we get? Just using power rule, that's 6x to the 5th plus 12x cubed plus 6x. And golly, that is the same thing we got using the chain rule. So that's pretty good. So again, we did not prove the chain rule here. I thought that was too complicated even for me. But we did 4 different problems, and we did them using the chain rule and using a different method, and showed that all 4 times we got the same answer. So that is pretty good convincing of the chain rule, I would say.